Thank you for joining us today. And in this video, we have like 5, 6, 7 questions that we want to go through together. Now, let's start from question 1. The idea of I have a graph, like for example, this one here, the question 3 that we are going to talk about. We have a graph, and then in the graph, we need to, compute these functions. Now, this comes with the idea of now you have the functions, and then you need to sketch. Sometimes it's very, complicated when information is given and you need to sketch a graph, right? So I'll try my best to explain some of the techniques and the skills that you need to learn so that you can go through it successfully. Now let's look at the first one. A is saying that not continuous at x is equal to 2, but limit as x is approaching 2 of f of x is equal to 1. Now, when we talk about continuity, we have 3 properties. 1, when I plug in A, if I'm talking about something A, then it should be what? It must exist. And then limit as x is approaching A of f of x also must what? Exist. And this happens when the limit as x is approaching minus A from the minus of f of x is the same as limit as x is approaching A from the positive side of f of x. If these two things holds, then this is true. Then the final one is saying that for the function to be continuous, then limit as x is approaching A of f of x should be the same as when I just plug in the value. So these are the three properties that we need to look at. Now let's look at the first question here. We can see that this question is saying that limit as x is approaching 2 is equal to what? 1. This implies from here that since this is equal to, since this right here is equal to 1, it implies that limit as x is approaching 2 from the positive side of f of x is the same as limit as x is approaching 2 from the negative side of f of x, and is equal to 1, right? So if they give us this, right, automatically, then this one implies that yes, the left and right are the same and they are also equal to 1. That's the reason why we can conclude that this is equal to what? 1. Now the function is not continuous at s is equal to 2 because now we know that, okay, this exists, good, but it can be that this does not exist, or this exists but is different from what? 1. So what you can see is now, since we have this one to be equal to 1 and this one to be equal to 1, so it means that we have the property 2 here satisfied. Now let's look at the top. So we can assume that f of 2 is equal to negative 1. So if that's the case, then we can see that this is not the same as this, which implies that the function is not what? Continuous. So the trick that I'm going to show you here is anytime the limit is defined, the left and right are the same and they are giving you the y value, and then it is not continuous at s is equal to 2, then what we have here is going to be called something like point discontinuity. The idea is that what is the x value here? The x value here is when x is equal to 2. So I will be on the graph and locate s is equal to 2. So anything here is for x, anything here is for y. So here it is 1. So that is when y is equal to 1. So that was what I'm going to get. Now you will see that now I'm going to have something like this. I'm going to use the whole because I know that this is what we call the point discontinuity. And we said point discontinuity have a whole, right? So now this graph, we don't have enough information, so we can say that this is it can even be a straight line because we don't know whether it's a quadratic or a linear function. So any way that you want to draw it, it's fine. So this is what you are going to get. This tells us that when I'm approaching 2 from the positive side, I'm approaching 1. And when I'm approaching 2 from the negative side too, I'm approaching 1, which is giving us the limit here to be what? Existing, right? But here is whole. There is a whole here because it is not continuous. So it means that f of 2 can be any value. So f of 2 can be like f of 2 does not exist, or f of 2, I can say that f of 2 is equal to 2, and then I can just plug it here and then do it. I will shade it like this. So this is how you can draw it any way. You can just make this one going down here, making this one going this way. The idea is that when I see the graph, I should be able to see that when I'm approaching 2 from the right, I need to get 1, and when I'm approaching from the left, I need to get 1. So what did I do? I picked the x value here, which is 2, and I pick the y value here, which is 1. I look at where they intercept, and then I draw my open here. I have some line here. I have some line here. Good. Now let's look at the B. Defined everywhere, and this is undefined. So as soon as this is undefined, what you need to know is the left and the right are not the same, right? Because if the left and then the right are not the same, then it means that this limit does not exist. It does not exist. So as soon as you see that the limit does not exist, then what you need to know is here we are going to talk about a jump discontinuity. The idea is that now here we are going to assume that the left and the right are not the same because it is undefined. So here limit as x is approaching 0, sorry, x is approaching 2, we can say that that one is equal to 2, right? And limit as x is approaching 2 from the negative of f of x is also equal to, let's say, 1. So you see that since they are not the same, there is a jump. So what you need to do is, anytime you are doing something like this, you pick the x. What is the x here? X is equal to 2, but we don't have y as for this. You see that this one we had x and we had y. So we were able to trace x, y, and they were meeting here. And then we have the left and then the right. This one we have only x, which is equal to 2. We don't know y. So meaning that y can be different values for the left and then the right. So I can say that from the left I have 1, and then from the right I have 2. So if from the left I'm having 1, then from the right I'm going this way. So this tells us that there is a jump discontinuity here, telling us that the limit is undefined, meaning that the left is giving us 1, and then the right is also giving us what? 2. Then here, because it's a jump, you can shade one of them, which will give us the idea of, okay, the f of 2. So the f of 2 can pick one of the holes. So if I shade this one, then here I'm assuming that f of 2 is equal to 2. Is that right? So that is what I'm assuming. If I don't do that and then I shade this one, then this one too, I'm assuming that f of 2 is 1. So this is how the graph is going to look like. So what you need to know here is that when it is undefined, we have a jump discontinuity. It means that the limit does not exist. Then when this one is equal to 1, we have a point discontinuity. Like when you have the y value, it's going to be a point discontinuity, something like this. Good. So that is what we are going to get at the end of the day from there. Now let's look at the 2. Now we have another information and then we want to draw this graph. Good. So for me, when I'm doing this, I try to look for the x values, right? So I can see there is 1 here, there is 2 here, and then the rest of the x values are infinity. So the one with infinity, that will be the last one that I'm going to plot. So I would like to plot the one with x values. Now let me start from the negative one. Now when I start from negative one, you can see that this function here does not exist, as we did here, undefined, meaning that does not exist. It means that this one here is actually what? Jump, right? So it means that limit as x is approaching negative 1 from the left, is not the same as limit as x is approaching -1 from the right. So let me assume that this is -1. So since there is no enough information for drawing this graph, for me, I can assume that from the left, it will approach 1. Yes, let me say something like that. And then let me say from the right, it will approach, let's say 3. Yes, something like that. So since I've gotten this image, I'm not going to draw the graph. I'll just give this one like I'm going to the left and this one to I'm going to the right, because I need to make sure I have all the information on the graph before I can connect the graph. So I cannot just draw this one. I don't know where they are going, so I just need to give it something small. Then when I'm done, I'll connect all the graph together. So now I'm done with this, because I know that it's a jump discontinuity because it does not exist. So you can make sure this one is 2, you put it here, the same thing. Right. Now the next one that I want to do is, now I can see that I have 2 here. So let me go and locate 2. I can put my 2 here, where here is 1. But at 2, when I'm approaching 2 from the positive side, I can see that I'm going to negative infinity. So I'm at 2 here and I'm going to the positive side. I'm actually going to negative infinity. Remember, any value here is for y. This is the y-axis. So if I'm going negative, this is the negative side of y. This is the positive side of y, right? So that's what you need to know. So this is the positive side. So when I'm approaching 2 from the positive side, what is the positive side? Whenever I'm doing it, I'll be like, let me put this here. So when I put this line here, this side is the positive side, this side is the negative side. That's what you need to know from when you want to sketch something like that. Good. So you let me even put the line there for you. So now this is the positive side. So the positive side, it means that when I'm moving from the 2, I'm just going to negative infinity. I'm just putting something small there. And then when I'm approaching 2 from the negative side, I'm going to positive infinity. So like when I'm approaching this, I'm just going to that. So this one too will be going somewhere like that. I think I didn't sketch this one well. So this one is like when I'm approaching 2 from the what? The positive side, I need to go something like negative infinity, right? So that's from here. Here, when I'm approaching 2. So when you say you are approaching 2, it means that when you draw this line, go to the positive side of 2, which is here, and approach 2. So like I'm approaching 2, I'm getting close to 2, but it's saying that I should go to what? Negative infinity. Then on the left side, what is here, when I'm approaching 2, we're saying that I should go to what? Positive infinity. So that is the idea. So I'm not done, so I'll just take this and that. Now the next information is this is infinity, this is infinity, so I'll do that one last. And let me look at this one. This one is s is approaching positive infinity and we are getting 2. Now one thing too that you need to know is, you see, we said all these values are for y, and this value we call them the horizontal asymptote, right? So this becomes the horizontal asymptote. So I'll go to the graph and locate my 2, and then I'll have my line here, which is my horizontal asymptote, right? Let me use red so that you can see what I'm trying to say. So this is my horizontal asymptote. Good. So now as x is approaching infinity, where can s approach infinity? Remember x is approaching infinity, this is the x-axis, right? So if x is approaching infinity, then it means that I'll pick the last x value. You see, I can draw it this way, but I know like I have x value here. So when I pick the s value, x should approach what? Infinity. So this is x is approaching infinity. So when x is approaching infinity, we are getting close to 2. So the more I'm going infinity, I need to move up and get close to 2, which is the horizontal asymptote, right? So I'm going to have something like, okay, if I'm going to If I'm going far away from x to positive infinity, I need to get close to 2. I'm not done. I'll stop here because when I finish, I need to combine some graph together. So I'm done with this one too. Now, when I get here x is approaching negative infinity. Where is negative infinity? Negative infinity is here because I'm picking it from the last x value. So you see that we have -2 here, we have -1 here, and 2 here. So with x is approaching 2, I pick it from the largest x value. So after 2, I don't have any information again. That's why I said for you to sketch for s is approaching infinity, you need to finish this ones first. So here, I have this one here. So after this, x is approaching what? Negative infinity. And this one should go to what? Positive infinity, which is the y. Remember, it's y. So it means that when I'm moving to the negative infinity, I actually need to go up. But one interesting thing is that with the horizontal asymptote, is good. We can even cross because we can cancel horizontal asymptote, and then that's all. So it's only vertical asymptote that is very difficult for you to cross because of why? Because the vertical asymptote, we are talking about what is under what? The denominator. And you know, whenever the denominator is 0, we know what happens. But the horizontal asymptote actually targets the top, right? So sometimes when the top is 0, we are not scared, right? So that is the idea. So when I'm moving towards this, I need to move positive infinity. So I think I'm done with this one too. So now what I'm going to do is I'm going to join the graphs, right? So as I'm moving this way, I saw that there is a graph also moving this way. So I need to make sure that I join them together. So I'm going to join this graph together like this. So if I want to draw it very well, then I can decide to clean the graph here. But I know that it's going up, and then just move it like this. Anyhow, like any way you want to do it is very fine. Right? Good. And then in the middle here, I see that there is a graph going this way. There is another one here. We don't know where this is going, so we need to make sure this graph and this graph join. And this one is going this way without any other one. So I can do this one like this and then move up like this. Good. Now when you come here, the last one is moving this way, another one too is moving this way. So what we need to do is we need to join this graph together. So I can, actually clean it and then do something like this. Good. So this graph here, tell us everything about the information here. So when I'm looking at this graph, I can see that, okay, when I'm going to positive infinity, I'm going to approach 2, which is here. When I'm approaching 2, when I'm getting close to 2, where am I going? I'm going to what? Negative infinity, which is right here. Sorry, which is right here. Then when I come to this stage, when I'm getting close to 2, where am I going? I'm going to positive infinity, which is also right here. Then when I'm moving towards this guy here, the 1 here, when I'm moving towards this one, I'm getting something like 3. Like with that one, we just assumed it. And then here to when I'm moving towards here, I'm getting something like 1, which is giving us the jump because this does not exist, which we said this is a jump discontinuity. And we said this is horizontal asymptote, right? So this is how the graph should look like. This is how the graph should look like. All right, now let's move to the next question. Okay, so the next question here is like, now they've given us a graph and we need to look at the graph and then, check it out. So it's very simple. So for me, anytime I'm just checking the graph, I'm concerned with where it is open, where it is closed, where it is open, where it is closed. Now the one which is closed, which is shaded, are always for f of something. So here that we can see that it's shaded, I trace it to the x. So the one here is like f of 1. F of 1 is for the shaded one here. When I trace this one to the y, now f of -5 is for this one. That's what you need to know. Okay. Now, whenever the graph is, whenever you have the graph and you want to pick this information, this is what you need to do. you look for x values where you can see the shaded one and then the one which is not shaded. I mean the close and not and then open. So I can see that I have open close here. So the first thing that I'm going to do is I'll have a line passing through this. Then I'll have a line also passing through this. Right? Good. So that's what I'm going to do. Let me just clean the one which is shaded so that I can see it very well. Now let's look at this right here. Now this one we are looking at x is approaching -5 from the negative side. X is approaching -5 from the negative side. So what is -5? This is -5. So the reason why I draw this is when I draw this, this will actually tell me that this is the right side of -5 and this is the left side of -5, so that I can draw the graph and do it. Now, as soon as I have this and I know that this is the left side, this is the positive side. Now I go to the left side, I look for the graph on the left side. So the graph on the left side is this one. Then I'm going to draw along the graph towards this graph here, not away from the graph, towards this line here, which is the -5. So when I look at this graph, I will just move along this graph towards this line. So on this graph, I get to this, which I'm on the line that I drew, right? Then I move to the y-axis, which is going to give us 4. So this is equal to 4. Yes, I said draw your lines. When you finish, this is from the left. Here is the left, here is the right, the positive. So when I see that this is the left and this is asking us for the left, look for the graph on the left, which is close to this. So we can see that the only graph here was this. So when I see that this is the only graph, I need to move along the graph towards this line, not away from this line, not like this, but rather this line. So when I move along this and I get to this line, I stop and then I'm here, which is 4. From the positive side, you see that all these are positive side of 5, but we want the one which is close to the 5, right here. So we can see that this graph is here. Now we are going to move along this graph towards this line. So I'll move along this here. When I get here, then I go to the y-axis, which is -3. So this is going to give us -3. Now, what will be the limit as x is approaching -5? One thing that you need to know is, you see, this is a jump discontinuity. And anytime you have a jump discontinuity, the limit does not exist. Now, this question comes into play. When we get here, I'll show you why. People will be like, this one does not exist, but it exists. Let's look at something here. So now we can see that this is 4, this is 3, and this is a jump discontinuity. So this does not exist. Why? Because the left and the right are not the same. The left and the right are not the same. So this does not exist. Now let's look at f of -5. F of -5 is equal to the one which is shaded. So go to when x is equal to -5 here and look for the one which is shaded. So we can look for this. This is open. This is closed. So we are going to pick the one which is closed. We trace it and we are going to get 4. Right. That's what you are going to get. Now let's look at limit as x is approaching 1. What is 1? This is 1, right? This right here is 1. So for us to conclude that this exists, then we need to look at limit as x is approaching 1 of f of x from the negative side and limit as x is approaching 1 from the positive side of f of x. Right. Now when you look at this graph here, let me clean the middle here small. When you look at this graph here at 1, we can see that this graph here is actually a point discontinuity. So that the idea of we calling this one a point discontinuity, we see that people will be like, okay, this does not exist. Why? Because it's a point discontinuity. No. When we are saying that it's a point discontinuity, the idea is that we are talking about continuity, right? And when we are saying that it's a point discontinuity, the idea is that, okay, the limit as x is approaching 1 of f of x is not the same as f of 1, right? Good. It's only the jump one that, yeah, it's a jump discontinuity, but the limit does not what exist because it's a jump. But the left, the only way to check is check from the left and the right, right? So here, what is the limit as x is approaching 1 from the negative? So this is my line. From the negative will be here, from the positive will be here. So I'm going to, on the negative side, I'm going to go along the graph on the negative side towards this line. So when I move along this graph and get here, then I move to the y, which will be 0. So this is going to give us 0. On the positive side, I move along the graph towards the line that I drew here. Then I move to this one too. I'm going to get 0. So anytime, one thing that you need to know is anytime you see that the graph is a point discontinuity, it means that the limit exists. So what you need to do is this one, if I don't want to check for the left and the right, I just go to where the point discontinuity is, because the left and the right meet at this point, and I just trace it to the y-axis, and then I get my y value. So this is 0, as we can see from here. Is that right? Good. So that is the idea. Now the question is also asking us for finding limit as s approaching 1 from the negative side, which we have already done it. So this is going to be 0. Then what is f of 1? So f of 1, we look for when x is equal to 1 right here, and we can see that we have one which is open and we have one which is closed. We pick the one which is closed. So this one, we trace it and we get 2. So this is going to give us 2 from the function, right? So this is the third question. Let's look at the fourth question. When evaluating limit as s is approaching either negative infinity or positive infinity of a rational function, how do you do it, right? So I will use the b here and then the e here, as the question is requesting us to explain what this means. But for now, let's start with this. Now we want to look at the limit of this as x is approaching 3 from the positive side. Now we said with limit, anytime you are doing it, the first thing to do is to do what? Plug in. So let's plug in. We are interested in the denominator, whether we are going to get 0 or not. That's where our interest in is. When I plug in 3 here, it will be 0. So the next step was for us to simplify. Now the equation is already simplified. We cannot do anything about the rational function here again. So what we need to do is we need to check the asymptote. Like we need to check the asymptote. And good, this is telling us that from the positive side. So when I draw my number line here and I have my 3, what is the positive side? This is the positive side. So it means that for us to test this graph here is actually going to give us either positive infinity or negative infinity, because we cannot simplify, we cannot do anything again. Only thing that we can do is when I plug in 3 here, I'll get like a constant divided by 0, and this should give us something like infinity, but we don't know whether the infinity is positive or negative. So this is going to tell us whether we are going to get it to be positive or negative. Now this plus here does not mean it's going to be negative infinity. That's what we need to test. This plus here means that we can pick any value on the positive side, like any value on the positive side of what? 3. So we can pick value which is close to what? 3 from the right side. We cannot pick from the left side. If the question wants us to pick from the left side, then this one will be negative, right? So let's pick a value like 3.1 and plug it in. So I'm going to have 3.1 minus 1 divided by 3.1 minus 3. This is going to be, the top will be positive. We are interested in whether we are getting a positive or negative. So this minus this will be positive, divided by this minus that will also be positive. Positive divided by positive will be equal to positive. So it implies that our function here is going to give us positive infinity. Right. That's what you are going to get. Good. Now let's look at the b as x is approaching what? Infinity. Then I will use to explain this. Anytime x is approaching infinity, we are talking about something called a horizontal asymptote, right? Which we have a technique where we need to look at if the top degree is less than the down degree here, then we are saying that the asymptote is 0, right? And then when they are the same, we just pick the coefficient. And when the top is greater than the down, then there is no horizontal asymptote. This is what we call it, like this. So for me to solve something like this, which is talking about horizontal asymptote, then I can use the idea of comparing what degree, right? So now here, since the degree of the top is less than the degree of the down, yes, this is going to be 0, because this is greater than this. But the other way that we can do it and see it better is, now I'll write this one as limit x is approaching infinity. I look at the polynomial on the top and I pick the term which is having the highest degree. So this. The one which is having the highest degree is this. So I'm going to pick 2x cubed. I'll leave the rest. I'm not going to pick this. Then I look at the denominator with the one with the highest degree. Oh, this one is out, so I'm going to have x to the power 5. This is what I'm going to do. The rest, I just throw them away. Then limit as s is approaching infinity. Now this will cancel this, so I'm going to have 2 divided by what? S squared. And this is going to give us 2 divided by infinity, small number divided by a big number, and we are getting what? 0. So that is what we are doing here. So with the rational function, what we are doing here is, 1, if the degree of the top is less than the degree of the down, then the horizontal asymptote is what? 0. Another thing that you need to know is, when the degree of the top, let me write example, is the same as the degree of the down, so plus 1, this is, let's say, plus x squared. So you can see that the highest degree here is the same as the highest degree here. What we are going to do is, the horizontal asymptote, or the limit as x is approaching infinity, will be the coefficient, which is going to give us 2 on 3. That is the idea with that. So I think, yes, I think this one is having the same degree. So you will see how we are going to get the final results here. Now, let's look at the C. Let's look at the C. So with the C here, now we have this. So the first thing that we need to do is, let's plug in -3 to the denominator. We don't want to struggle, and maybe the thing is just plug in and you get the results. So I'll plug in -3 squared plus 5 times -3 plus 6. This one will be 9 minus 15 plus 6. This is 0. Okay, so the denominator is 0. So it means that the idea of direct substitution will not work. Let's talk about simplification. Let's try and simplify. So if we want to try and simplify, now x squared minus 9 is the same as s squared minus 3 squared, which is difference of 2 squared. So x minus 3, x plus 3. So the top will be x minus 3, x plus 3. So that is good. Now let's try and break down the denominator 2 and see if we can do some cancellation here. Now, what are the factors of 6? So here, for us to solve, we need to look for, this is 1. So 1 times 6 is still 6. So we are going to have 6. What are the factors of 6? 1, 2, 3, and 6. I think so, yeah. So we are going to pick 2 of the factors that when we add or when we subtract, we are going to have this one here. And when you multiply 2, we are going to have what is here. Right. So the only factor that we can pick is this, because 2 plus 3 is 5, and 2 times 3 is 6. When you pick 1 and 6, 1 times 6 is 6, but 1 plus this, it's not 5. So what you are going to do is, this is x squared plus 2x plus 3x plus 6, and then x out, x plus 2, 3 out, x plus 2, and this is the same as x plus 2, x plus 3. You know what I did here? This one, I factor one of the x out. So when I factor one of the x out here, we'll be left with x, and here we'll be left with 2. Here I factored 3 out. So when I factor 3 out, here will be left with x, and this one will be left with 2. This and this is common. So I write it, and then I pick this plus this as this. So the denominator is also going to give us x plus 2, x plus 3. So good for us. Now we can see that this will cancel this, right? Oops, I need to bring the limit. So this is going to be limit x is approaching -3, and then x minus 3 divided by x plus 3. Now, as I said from some of my videos, when you are done with the simplification, you plug in again and see if it's going to work it for you. If it's going to work for you. Let me see. This is supposed to be 2. So now we are going to have -3 minus 3 divided by -3 plus 2. Then we have -6 divided by -1, and this is going to give us 6. So this is going to give us what? 6, which is very nice. So that will be the limit there. Now let's look at this one here. Now this limit is we want to find limit as x is approaching 2, right? But we have one which is the left, and we have one which is the right. So this one is like two functions. We want to find the limit as x is approaching 2. But for us to conclude, we need to find limit, because you see that if x is less than 2, then it means that we are on the left side. And if x is greater than 2, it means that we are on the right side. So we need to pick limit x is approaching 2 from the left. And then left side function here is this. So we are going to have 1 minus x. Then we are just going to plug in the 2. This is just to show us that we are from the left. So we are going to have 1 minus 2, which is equal to -1. Then we pick limit as x is approaching 2 from the positive. So from the positive is when x is greater than 2. So this will be the function. So this one will be 3x squared plus 1. Plug in 2, 3 times 2 squared plus 1, 3 times 4 plus 1. This is 12 plus 1, and this is going to give us 1, 3. So what will be the conclusion on this? We are going to say that this limit here does not exist. Why? Because the left is not the same as what? The right. So looking at this, we are going to say this is equal to does not exist, right? Good. So that is the idea with when you see a function in a bracket like this, you pick the left, you pick the right. If they are the same, then this will be, so let us assume that this one was 1, -1, this one was also -1. Then limit of the whole of this will be equal to -1, right? So that is the idea from there. Now let's look at this one. Now limit as x is approaching infinity, as we learned. If we are using the idea of comparing degrees, then we can see that the highest degree from the top is 5x squared divided by the highest degree from the down here is 3x squared. So the horizontal asymptote or limit of this will be the coefficient of this, which will be 5/3. Very simple. Another way that we can do this is, as I said, we are going to write the limit x approaching infinity. The same thing, I pick the highest degree, which is 5x squared, divided by the highest degree on the down, 3x squared. X squared will cancel x squared. Then limit as x approaching infinity, 5/3. Now limit of a constant is the constant. So this is going to give us 5/3. So that is the idea or the explanation that we are going to give you to this whenever we want to do something like x is approaching -infinity or positive infinity. We need to compare the degrees and the ways to do that. Last question on this problem here is going to be so first, as I said, first let's plug in 1. When I put 1 here, 1 squared 1 here will be 5, it will be 0. So what we need to do is we need to try and simplify. So let's look at the top, 2x squared plus 6x minus 8. Now I need to multiply 2 to 8, which will be 16. So I need to pick two factors of 16 such that when I add them, I'll get 6 in the middle here. And then when I multiply them, I'm going to get 16. So it's supposed to be negative 16. I'm going to get negative 16. So what are the factors of 16? 1. So it will be plus or minus. So I'm just using positive. 2, 3, think about 4. 4 for 16. So 3 times what will give us 16? 3, no, 3 is not part. Then we can talk about 8. So I think, and then we can talk about the 16. So I think 2 and 8 will help because 8 minus 2 is equal to 6, and then 2 times negative 2 will be negative 16. So 2 and negative 2, 2 and 8 will help. So let's use them. So this one will be 2x squared plus, or let me say minus 2x plus 8x minus 8. Then I'll pull 2x out. Here we'll be left with x minus 1 plus, here when I pull 8 out, I'll have this. So that's what I'm going to get. I have this and this to be common, x minus 1. Then I'll combine 2x plus 8. So that one will be the numerator. So the numerator will be x minus 1. When I finish, I'll write the limit. Then 2x plus 8 divided by, now I need to look at the denominator too and simplify. X squared plus 4x minus 5. So this is going to be two values of 5. That is going to give us, so 1 and 5 will work. So x squared plus, okay, let me say minus x plus 5x minus 5. Good. I think this one will work. So when I factor x out, x minus 1. When I factor 5 out, x minus 1. So x minus 1, because it's common here, then I'll combine x plus 5. So the denominator will be x minus 1, x plus 5. So that's what I'm going to get at the end of the day. So let me write my limit. Limit x is approaching 1. So good for us, this will cancel this, which will take what is making the thing, what will making the denominator to be 0. So it will be left with limit x is approaching 1, 2x plus 8 divided by x plus 5. And then when I plug in 1 plus 8, 1 plus 5, 2 plus 8 divided by 6, and I'm going to have 10 divided by 6, which is like 5 divided by 3. So that was what I'm going to get from this question too as well. We have another question again. Oh, okay. I have another question here. Okay, so now here we also want to calculate limit as h is approaching 0 of this here. This is so interesting. So this is just equal to limit h is approaching 0. Then let's try and expand this. So I'm going to have 3 open brackets. Now one thing that you need to know is if I have 2 plus h all squared, this is the same as 2 plus h, 2 plus h. This is what I can, like, this will be the expansion. And then when I multiply, I'm going to multiply 2 by 2, 2 by h, then h by 2, h by h. So I'm going to have 2, 2, 4, 2 times h, 2 times h, and then h times h. So this is going to give us 4 plus 4, h plus squared. So x squared is this. And this one you can also use a Pascal triangle to do it if you want to do. So in place of this here, I'm going to replace it by this. So I'm going to have 4 plus 4h plus h squared minus 12 divided by h. So limit h is approaching 0. I'll multiply 2 by 3. I'll have 12 plus 12h plus 3h squared minus 12 divided by h. 12 will cancel the 12. So we are going to have 8 is approaching 0. 12, 8 plus 3, 8 squared divided by 8. This is the same as limit 8 is approaching 0. 8 is approaching 0. On the top, I can factor h out so that I can cancel it out. So h out, we're left with 12 plus 3h divided by 8. This one will cancel this. I'm going to have 8 is approaching 0. 12 plus 3h. Then now I can do substitution because what is making the thing undefined at the denominator is now gone. So this one will be 12 plus 3 times 0, and I'm going to have 12. Very simple. So that is what we need to get from the limit from there. Then let's look at the 7. I think the 7 is the last question. So we have f of x to be this. We need f of x plus h. So as I said, anytime I have a function, I try to put all my x into what? Parentheses. So for I put my x into parentheses, I have this, which is going to help me to do my expansion for this. So what I'm going to do is I have x here, I have x here. So I'm going to write the same thing, but now my x is changing to x plus h. So I'm going to change all the one in the parentheses to x plus h. So I'm going to have 4x plus h minus 7. And this will be 4x plus 4h minus 7. So that will be the function. Now when you look at this one here, I have f of x plus h, which is here, which is this. Then I have f of x, which is also equal to this. Right. So I'm going to have 4x plus 4h minus 7 minus, I'll put it into what? Parentheses. So anytime you write minus, you need to put the function into what? Parentheses. Minus 7 divided by h. Good. So what will be the results? This one will be 4x plus 4h, right? Minus 7. Then I'll multiply to the minus 4x plus 7 divided by h. 4x, 7, 7. And this is going to be 4h divided by h, and this is going to be 4. Now last question, we want to find limit of this. And remember, the one here is what is here, and is equal to what? 4. So this is the same as limit 8 is approaching 0 of 4, and limit of a constant is a constant, which is 4. So anytime you are talking about, I'll talk more on limit definition, but anytime you are talking about something like this, limit of something, like you have using limit definition, when you are done and you get your result, what you need to do is, I'm showing you the trick here, differentiate the function and see if it's the same as this. Now when I differentiate 4x, I'll get 4. When I differentiate minus 7, I'll get 0. So you see that when I differentiate this one here, I'm getting 4. So this tells us that, yes, what we did is what? Right. Good. Thank you, and see you in the next video.